In this video, we're going to learn about elastic potential energy. So it's defined as the energy stored in an object when it is deformed elastically. And so that can mean either stretched or compressed. So you want to think things like springs or strings that stretch and things like that. Like all energy, elastic potential energy is a scalar value and it's measured in joules. The formula is given as EH is equal to 1/2 K delta X squared. So K is the spring constant in newtons per kilo, and delta X is the displacement from the equilibrium position, which is the M. And so the H, some people, why is it called H? That's coming from Hooke's law, because springs that have a spring constant value obey Hooke's law. And so that's why the elastic potential energy is defined as EH. So we're going to get into some examples. So we have a spring with a spring constant 820 newtons per meter, and it's compressed by 50 centimeters. So this is a large spring. Calculate the elastic potential energy stored in the spring. And so the main thing we want to do here is we have to understand that this 50 centimeters, we got to convert that into meters. And so in order to use the formula, we have EH equals 1/2 K, which is 820 newtons per meter, and then 0.0 meters squared. And that leads to a value of 102.5 joules. And so this is the amount of energy stored in that spring. In this next example, we have a 25 centimeter light spring is suspended vertically and has a spring constant 400 newtons per meter. A mass is attached to the spring and extends to a length of 34 centimeters. Calculate the elastic potential energy stored in the spring. So there's a few key words here. Light spring, the reason they identify that is just to make sure that we don't have to really consider the mass of the spring when we're talking about the forces acting on the spring. So we're just looking at the whatever mass was attached to it. Now we don't know what the mass is, but we know the extension of the spring. And so the extension of the spring, the change in x, is going to be equal to 34 minus 25, which is 9 centimeters. And so the elastic potential energy now stored in the spring is going to be 1/2 times 400 times 0.09 squared. And the 0.09 is, we got to make sure that the displacement here is in meters, not in centimeters, and we get a value of 162 joules. And so that's the amount of energy stored in the spring. In summary, when we talk about elastic potential energy, it's this energy stored in a deformed object. So it's either going to be stretched or compressed, and the amount of elastic potential energy is proportional to the spring constant K. The amount of elastic potential energy is proportional to the square of the displacement measured from the equilibrium point.